Working with data frames can feel overwhelming, especially when you have multiple columns and need to apply specific conditions. You are not alone in this struggle. Many data analysts face similar challenges. Here is the specific situation we're looking at. One user recently asked, "How can I use a Boolean mask on multiple columns in my TNAC?" They provided a TDEMP with measurements and uncertainties, and they want to filter rows based on certain conditions. Sound familiar? Let's explore this together. So, what are the issue here? The user has a DTime with measurement columns and corresponding uncertainty columns. They want to create a Boolean mask to filter rows based on their defined criteria. This is a common task in data analysis, and we can definitely tackle it. And stick around. I have a powerful tip at the end that will help you streamline your data filtering process even further. To start solving this problem, the user needs to apply the Boolean mask to filter rows based on the conditions for each measurement column. We'll use the Boolean array directly to filter the DMAC. Next, the user can select the rows where the condition is true for a specific column, such as column A. This can be done by using the Boolean mask directly. Now, to find rows where the condition is true for all input columns, the user can use the logical and operator to combine the Boolean masks for each column. Lastly, the user can display the resulting data frames to review the valid rows for both column A and for all columns combined. Fun fact: did you know that the term data wrangling comes from the idea of wrangling cattle? Just like herding cattle, managing data can be a bit chaotic. Now, let's look at the answers provided by other users. Any Hackutes 1as. Finally, to select rows where all columns are true, use def results for all atixer 1a. Now let's dive into a different answer from another user. An alternative approach suggested by another user involves using a vectorized method with NumPy. They create a list of relevant columns and their corresponding abbane. To filter the TMID, they use NumPs, where function to set invalid entries to none. This allows for easy identification of valid measurements. Additionally, to find rows where all conditions are met, they utilize the all function along the rows. Here is that powerful tip I promised. Always double-check your conditions and consider edge cases. This will save you time and ensure your analysis is accurate. And there you have it. You now know how to apply Boolean masks on multiple columns in a Pandas speedup. Remember, practice makes perfect. If you found this helpful, hit the subscribe button for more tips and don't miss our next video where we dive deeper.